The broadcast is now starting. All attendees are in listen-only mode.
Well, hello everybody, and welcome to Coffee with Caleffi. Bob Rohr. I'm up in Milwaukee this week, so it's kind of fun catching up with everybody here. The topic today is piping connections for hydronic heating systems, and so what I want to do is just go over some of the connections that you guys are probably familiar with, some of the new connections that are out there, and of course talk to you a little bit. Excuse me, I got a bit of a cold today, sorry. Talk to you a little bit about how Caleffi can help you with these connections, and we're looking at what's coming down the line, and we're trying to stay ahead of all the new technology for putting pipe and stuff together. So, all right, so these are our hydronics up to date. We just came out with the number 18 there on water quality. We don't have an hydronics issue on the topic that we're talking about today. Again, if you're not getting the hydronics mailed to you, go to our website and sign up, and we'll make sure that twice a year when we send these out that you can get them mailed directly to you. So what I want to look at is the common connection types that you're probably going to see out there, that you are seeing out there, and so I kind of broke it up in two categories based on the size. And so below 2 inch, probably still one of the most common pipes you're going to see out there is a sweat connection, and I actually did a little research on that this morning, and I think Mueller takes credit for one of the first solder fittings out there back in 1930. They developed what was called the Streamline. I can remember these boxes when I worked with my dad. It was just a brown cardboard box with a blue lettering on it that said Streamline. And I think it was Mueller that had this thing. If you found a defect in one of their fittings, they would give you $5 for every fitting that had a, had a marker, wasn't extruded right or something when they made it. So not a lot's changed over the years in sweat fittings. We do have some low lead brass. We'll talk about that as we go. It does solder a little bit different than some of the leaded brass. Threaded connections, again, that's been around for a long time. When we refer to a threaded connection in the U.S., it's typically a national pipe thread, a tapered thread. There are some straight threads out there. We're going to look at what the difference is between a NPT tapered thread and a BSP, which is a straight thread. Unions, a lot of different types of unions. Probably most familiar with what we call ground joint unions that might be used on steel pipe, maybe on gas piping or something like that. There's also dielectric unions that are a transition union between, threaded. Maybe if you've got a galvanized at your depth in copper, you might use a dielectric union there. And then also just a gasketed union. It could be just copper to copper with a gasket between her, an O-ring between it to make the seal that. And then the next one I want to talk about is press, and this is gaining a lot of steam. It's been around. I would probably credit Viga with bringing the first press fittings over to the U.S., and I think they've been out there at least 20 years now, maybe closer to 25 years. But this is just a copper brass fitting that you slide on. It's got an O-ring seal in there, and then a tool goes around it, and it just squeezes that into a shape, and it makes the connection that way. The copper's been around for a while. Now we see guys are pressing stainless steel. I know there's a press fitting out there for steel pipe, like gas piping. And I think I saw one at the ASHRAE show that there's a press fitting available now for refrigeration tubes. Probably has a different gasket or something in it. Excuse me. Compression. Probably most familiar with this on like a stop under a sink or something like that, and basically it'll be a ferro connection. We use a type of compression fitting on our radiant manifolds where you put the PEX tubing in the bottom of the manifold. It'll have a little ferro around it, have an insert in it that keeps the pipe round, and it makes the seal on the end of it. We'll look at some of those. The grip fitting, I consider this more of a homeowner type of product, or maybe a do-it-yourself type of product. I'm talking about the ones where they've got a stainless steel gripper ring in there, an O-ring, and you just slide it over the PEX, you slide it over the copper, and it just grabs onto it, and you got a little release tool if you want to take that apart. The barbed insert, that's a PEX fitting. That's where we would slip the PEX fitting inside the tube, and then it'll have either a stainless steel collar that crimps around it, or a copper ring, or maybe it'll have like an Oetiker clamp that you pinch around it. On the larger sizes, flange type of fittings, that's kind of a picture there of a flange fitting, and oftentimes that can be a transition fitting where you're going from a threaded connection to a sweat connection. You can get transition flange fittings, but basically another gasketed fitting that has a bolt pattern to it, and it'll have a fiber gasket between those two, or it could have an EPDM gasket depending on what the the temperature requirement of the fluid that you're putting in through it. And groove has been around for a while. Basically, you take a steel pipe or even copper pipe, and you can either push a groove into it, or on steel pipe you can actually cut a groove out of it. And then a rubber gasket goes over those two pieces, and then there's a collar that goes around that latches into the grooves. Nice about that, it allows for some movement, so if you've got to have a little bit of flexibility into it, you'll see a groove joint used. I think I just saw in one of the magazines that Victrolic has come out with a groove gasket fitting that can be used for steam now. So. And lastly, on the bigger stuff would be a welded, obviously a fabrication shop, or you could do this on the site where you're going to weld it. And one thing I want to caution about welded, I know some of the guys, when you see some of these big steam installations, guys said, oh yeah, I made this beautiful header that I welded up. Well, on a steam boiler, you got to leave some room for expansion as the boiler heats up. So if you weld a header across there, you can have the potential to crack some sections when that boiler heats up, and it needs something to move as it expands. And with a threaded fitting, you've got that the ability to allow that fitting to move a little bit when the temperature changes through it. Now, piping materials, here's something that's changing. I think every year we've got a new material out there. Steel's been around forever, you know, threaded pipe. It could be a groove pipe. It could be a welded pipe, copper pipe. Probably most familiar with the different types of L, M, or K type of copper, just a different thickness of the wall. Plastic and composites, probably where we're seeing the most amount of change right now, and that's an example in the picture there of some of the new, what I call fusion weld, where you actually heat the socket of the fitting and you heat the pipe and you smush them together, so to speak, and it actually, you know, pretty much welds itself together into one piece like that. One of the brands there you can see in the picture, I believe that's an Aquatherm brand. I know there's some other brands out there, but what we've been seeing up until now is that's typically guys are using this in the larger, like 2-inch and larger sizes. I know it's a bit of an investment to make to get all the tooling to be able to put that together, but I think you'll see more and more of that as time goes by. Then the PEX, which really stands for polyethylene, and the X at the end means it's cross-linked. So the PEX tubing that we use for radiant and for domestic water systems will be a polyethylene tube that's been cross-linked with one of the different methods out there. The Geo guys will use just a straight PE, just a polyethylene tube. It's not a cross-linked tubing. We're not as concerned about oxygen ingress, which is what we're doing when we cross-link it, is we make it limit the amount of oxygen that can diffuse through the wall of it. And then we're looking at stainless steel. See a lot of this wherever there's food industry or chemical industry. That can be a welded. It can be a press fitting. There's threaded stainless steel nipples that you can buy at wholesalers and stuff like that. And then a stainless steel corrugated, and we got into this when we started introducing our solar kits, and basically it's a corrugated, almost like the copper flex connectors that we've used on water heaters for years, made out of stainless steel, and it's real nice if you're going, you know, through an attic or you got to fish it down a wall or something like that. It's very flexible. The corrugated stainless that we offer is pre-insulated. In fact, it's even got a wire in it. So if you're going to run it up to a solar collector, for example, you've got your insulation, you've got your tubing, and you also have your wire in it. I know some of the companies are looking at that for a replacement for copper tube and domestic water piping. I think one of them out in California, they're trying to promote a corrugated stainless steel tube as a domestic water piping system. And also you've probably seen them over the years in gas flexes, where you would connect a water heater to a gas line and you want a little bit of movement in there, like maybe if you're in an area where you're required to have seismic restraint on your water heater, you might use a stainless flex connector so that if the ground in the water heater starts shaking, you're not going to break off a threaded connection. Yeah, I put this slide up here, mind your P's, and basically whatever type of material you're using, whether it's threaded, whether it's copper, whether it's pressed, you really want to pay attention to the prep work, because it's really the prep work that's going to make the difference in the quality of the joint, the quality of the connection, the longevity of that joint. And here's some of the common things. I tried to mock this up in my shop last week. Some of the most common mistakes we see with the different types of threaded joints is too much pipe dope on the inside. Now, I know guys that do bigger, larger sizes, 2-inch and up, like to put some of the pipe dope on the outside of the pipe that's going into it and maybe go around the inside of the fitting with a little bit. But just be aware, if you overdo that, you're going to have a buildup of that gets pushed in along with the nipple. So now if you start circulating fluid through that, especially in a hydronic system where we've got some temperature, you've got the potential to wash some of that pipe dope or whatever you're using for your compound into your system, and it can get into your pumps, can get into your zone valves, can get in all your components. So I guess the bottom line is just don't overdo it with any kind of a pipe joint compound. And the same thing over there to the right, let me get my little cursor here going, is with Teflon tape or with joint tape here. Be careful when you use that. If you go off the end of it, like I showed in this picture here, and you screw it in, this is what's going to happen. It's going to shut. You're going to have shards of Teflon tape, and that's going to get in your pumps, it's going to get in your valves, going to get in your boilers. Always start back a thread or two when you use this type of tape. Some guys like to put some piped up over some Teflon paste over the outside of the Teflon, holds it on the pipe a little bit better. What I did over here on the right in my shop is I cut a bunch of pipe with the different methods that we use for cutting tube. And some of the things that you might find inside the pipe after you've cut it, like if you're reaming the steel pipe after you thread it, and after you cut it with a displacement cutter, you're going to get some of the reaming byproducts of the shards in there. If you're cutting with an abrasive cutter, you might see some of the, let me reduce my menu here. You might see some of the shards when you use your pencil reamer from the copper tubing, or if you're using a chop saw to cut your copper tube or your plastic tube, whatever, just make sure you shake that out, because that's going to end up in your pumps, it's going to end up in your system. And down here on the bottom row, what I'm showing is just a sweat copper connection there, and I'm showing it with too much flux. And it's the same thing here. If you overflux this fitting on the inside and the outside, number one, on the outside, it's going to run down the pipe, and you're going to have a bit of a mess that you have to clean up. But inside is where we're really concerned about. If you end up with like a big gob of solder flux here, and what happens now when you solder that and heat that, it's going to run down inside your pipe, and then you start flowing the water through, and now you've got, that mixed in with your system. So I think what you'll find if you read the side of most of the solder fluxes, there's chlorides in the solder flux. And one of the issues with stainless steel and aluminum boilers specifically is the chloride levels. The manufacturers are going to give you a number that they want to keep those chloride levels below. Well, if you end up with a lot of solder flux inside your pipe, you're actually increasing the level of chlorides in that system, and more potential for corrosion. This is actually our lab over in Italy, one of our test benches there. So here's an example of, we piped this with stainless steel pipe, and you can see mostly flange connections there. These can be prefabbed at a shop where they can actually weld the flanges on the end of the stainless steel and then just make up these Venturi tubes that we use for doing our flow testing on some of our different devices there. But a lot of shops that are going to use a test lab where there's water splashing around, you're trying to keep it clean, you want to be able to make it look pretty when you're showing people around, and we use stainless steel pipe because it cleans up nicely and it stays like that without showing any signs of rust or corrosion. Here's an example of the stainless steel corrugated flex. This is our solar flex here. So basically to make a connection on this, you cut this off with a typical tubing cutter, displacement cutter. Carefully, this is a very thin tube, so you got to go around there and just a little bit of pressure on the cutter as you're doing it so you don't end up with a real sharp edge on it. And then all you're going to do is just flatten the end of that. It's similar to like you make a flare connection on copper tube or on a brake line on a car, for example, where you'd use a single or double flare. That's all we're doing is making a flat surface at the end of it. So now we put a fiber gasket at the end of this, and that's what's going to make the connection over here on the right on the solar collectors or whatever fittings we use. You'll see a fitting like this sometimes using some of the gas flex that's out there. They'll either use a flare type of fitting or they'll flatten the end of it and use a gasket like that. So the other choice is when you start looking at fittings is what's it going to, that's an old picture of me, where did that come from? I haven't seen that in years. Is it a permanent connection? If it's something that never has to be taken apart or opened up for any reason, again, that could be a weld, that could be a press. Those are two types of connections that you don't easily get apart to change something. You'd have to pretty much solve that out and start over. If you have something that you need to disassemble for whatever reason to service it or work on it down the road, that's where we'd use a union of some sort, either a ground joint union or a gasketed union or a dielectric union on the top of a water heater, for example. If it's real frequent service, I mean, maybe we'd use a hose connection, like a garden hose connection, or I know a lot of guys that use transfer pumps or pumps for pumping in their solar fluid, just use some wash machine hose with a typical garden hose connection at the end of it. And then you can buy different assortments of flex connectors. And that you would use a flex connector if you got a misalignment, like you've got a couple tanks where the nipples don't line up exactly right. It'll allow for some expansion also if you got a tank where you're going to have a lot of temperature change and you're worried about some expansion. Also in vibration, a lot of times when big pumps are put into a system, they'll put a stainless steel flex connector between them that'll take some of that, prevent the noise and the vibration from that pump, transfer them through the building, through all the piping in the building. And here's a couple examples of that. Great picture here, by the way. Thanks to these guys for sending this in. Some flex connectors used there between the big components there. Now that could be for vibration, so they don't get vibration or noise from the pumps and the equipment that are connected to that. You can have these made in a lot of different configurations. There's a number of companies. We use Metroflex out of around the Chicago area, and you just tell them the size you want. You tell them the type of connection. They can put a union. They can put a straight nipple on that. They can put a flange like you see here. So typically, excuse me, these are going to be built to whatever configuration that you need for the job. You call it in, give them the spec, and they'll make that. It'll be based on the temperature, the type of fluid you put through it and stuff. Another example there, you can see a flex connector between that copper header pipe down there and the, not sure what that is, if it's a big boiler or a chiller unit or something. Yet another one, and these come in all sizes. Some guys, when they put air handlers in or something like this, they'll use a connection like that again to keep the vibration from transferring through the pipes and into the building, where you can hear the equipment running, either the air handler vibration or from the pump that might be connected to that. Solder flux, again, I talked about this. Just be careful with the flux when you do it. Don't overdo it. I know some of the plumbers I know actually will use a sponge. Mark Etherton taught me this trick, that he uses a sponge in this flux instead of using the brush, and he said that way he doesn't have the tendency to overdo it. Ream in the copper at the end here when you cut it. Make sure you get the ream out. One thing that you'll notice is that you're seeing more and more no or low lead brass products coming on the market. Anything that has potable water in it by code has a low lead or no lead brass used in it. It is a little bit different to solder. Some guys have had a little trouble learning how to solder the low lead brass, and basically what happens is when you heat a fitting like that, typically when we solder a connection like this, we'll take the torch and we'll put that flame and we'll kind of concentrate it at the back of the fitting here at the base of the hub. And what that'll do is the solder will pull into the hottest point where the torch is. Well, what happens with this low lead solder is it expands differently than the leaded type of brass, and what will happen then is the fitting will expand and the fitting gets warm, but the pipe doesn't. So if you look at some of the videos that have been put out there by NIBCO and different people that are making low lead brass components, they're saying you might have to move your torch out and warm up the pipe a little bit as you heat the base of the fitting to make sure that the pipe is getting warm at the same time the brass does. Otherwise, the solder will draw into the brass, but it's not going to stick to the copper because it hasn't warmed up because it expanded a little bit. And there's a classic example of the way to solder a fitting. You can see he's got the tip of his flame right at the base of the solder joint there, and that'll, when you see the solder flux bubble, start adding your solder to it. Excuse me. As soon as that happens, you want to take the heat away. Once your solder melts and goes around that joint, there's no reason to keep your torch on there, and that's usually what causes the solder joint to fail, is somebody's overheated it. Once the flux burns black or something like that, just stop what you're doing, take it apart, and start over, because if the flux burns, you're not going to get a good joint in there. I think the other thing that happens sometimes is people tend to use too big a torch tip. Maybe the day before they were soldering a large diameter copper, then they go where they're going to do like a 3/4 zone valve here, and they've got a big rose bed or a big a turbo torch tip, and they overheat the fitting in the tube when they go to solder it, and then they burn it and they get a bad solder joint. All right, we'll talk about threaded connections. So the most common threaded connection, I say the most common, in the U.S. and Canada, everything is NPT, a tapered pipe thread. The rest of the entire world uses a BSP or a straight thread, and they put it together with a gasket or some other type of seal. But what we do is we thread things with a tapered thread. Sorry, I've got a little bit of a headache and cold going on. So there's a couple different threads actually. We typically use just an NPT thread, but there are different versions of that. This one here is called an NPTF. Sometimes people call that as a fine thread. And that's a type of thread that actually makes a seal on the thread. The way that thread is built, it actually collapses the crest, what's called, on the thread. I'll show you that on the next slide, and it actually makes a seal. If you're going to do a standard NPT thread, you need to put something in there to make the seal. The thread will never make up. There's going to be a space. And let me just go to the next page and I can show you. It's a couple pages away. You can see it up here in the picture. There's going to be a space between the top of it, which is called I think that's called the crest and the root of the thread there. So something has to go in there to fill in that space, and we're going to use pipe dope. We're going to use Teflon tape. Maybe some of the gray beards that have tuned in today remember the day when we used lead paint as our pipe dope, because the lead would lubricate that thread, allow it to seal with the lead in there. So you don't want to overdo it on this type of joint, because you can split a fitting like that. If you just keep cranking and cranking, maybe you want this to end up in a certain position. Because it is a tapered thread, you can actually jam it in there so far that you can split the end of the hub, especially on a thin fitting like that. So just be careful of that. And the same thing like I talked about earlier, just a couple wraps of Teflon tape. I like to use that new, I think it's called 3-wrap, where you just go around it 3 times, and that's all you need to do. Screw it together and away you go. the limitations of this type of thread is you never really know where you're going to end up. So if you've got a bunch of fittings on the wall and you go and you measure all the pipe between all those fittings and you start screwing it together with a tapered thread like this, you pretty much have to keep tightening that until you get that bounded or you make up your leak-proof joint. The beauty of a straight thread is you can stop pretty much anywhere. So once you get 2 or 3 threads into the thread on a straight and BSP type of thread, you can stop. So now as you measure all your pipe and all your fittings, you're always going to end up in the perfect spot. So the other thing to be aware of with a threaded pipe is the quality of the thread. You know, look at the fittings that you're buying and the nipples. If you're buying threaded nipples from your supplier, I don't know if it's the type of steel that we're using these days or they're not using the right lubrication or just bad die segments, but it's not unusual to see a thread that's ripped a little bit like that. And if you've got big gouges and big rips in that, you really need to just, you know, get rid of that and start over and rethread it or get a different nipple, because now you're dependent on all this, the pipe dope and the Teflon in there to make the seal when it should really be made by the, you know, the thread itself, not by the compound you put in there. The length of the thread, I mean, my dad always taught me just, you know, thread this until you got 1 or 2 threads sticking out of the end of the die, and that's enough. If you keep threading and you get a real long taper thread and now you go to put that in the fitting, you know, you've got too long of a taper and you might not make up before you bottom out the end of the fitting. So here's the other one, and these we started to see a lot of as we started bringing more stuff over from Europe. Some of the very first boilers like the Badaris and Beastmans, if you guys have worked with those, if you remember, they came with BSP threads on the indirect tanks on the boilers, so then you had to have an adapter in there to be able to get down to the pipe thread. So you can see the difference here. There's no taper to this type of thread, so this thread is going to have to make up its seal with either a gasket or some other means of sealing that. Now what we do when we make up fittings here, we make up our manifolds where we're going to use a BSP thread is we'll use a Loctite product on there, and basically this is a super glue is what it really is, and it just goes in there. It's an anaerobic type of sealant, and it goes off, it seals in the absence of oxygen. So you put that in there, and 15 minutes after you put Loctite on this and screw that together, it's done, and you won't get that apart again without either ruining the fitting or breaking it or collapsing it. So that's another way that you can put a BSP thread together if you don't have a gasketed seal at the end of it, where it's just a thread to thread like in the side of a boiler or an indirect tank or something like that. It's just, there are special Loctites made for doing that. It's not just a nut and bolt. We use a 545, and I think the other one's a 272. I don't know if you can read it on here, but it actually says it's for hydraulic and pneumatic fittings, where they don't want to put like Teflon tape or something inside a pneumatic connection or a you know, some type of equipment that you don't want to have anything inside of it. They'll just use a Loctite and they'll just actually glue it together is what we're doing. This is sometimes known as a G thread on manifolds and different things. They say, well, it's got a G thread on it, and that stands for gas, but it will be this BSP type of connection. And there, of course, there's different sizes of those, there's different versions of that type of thread, but that's the main difference, is it's going to be a straight, it's more like a nut and bolt type of thread than a pipe tapered thread. A little tip about this: if you do put a connection together with Loctite and for some reason you have to take it apart, all you have to do is just get a torch and warm that joint up. Don't heat it up to 400 degrees like you're trying to melt solder, but just warm it up a little bit till you smell like kind of an oily smell, like something's burning, and then you can just screw it apart with the pliers or a pair of gloves and you can take it apart. We actually, in Europe, we make what's called a hemp thread, and this thread, I don't know if you can see it in the picture, it actually has little cross cuts in it, a little serration, so to speak, in it. And what it'll do when you use hemp, or if you use some of this Loctite string on there with those little segmented kind of serrations in there, it'll grab the hemp or grab the tape that you put on there, so when you screw it together, the tape doesn't wind off the end of it, and you end up with your hemp or your tape on the outside of the fitting instead of inside where it's supposed to make the seal in there. So Loctite still makes that string. It almost looks like a dental floss that you can buy, and also you can, in Europe, you go into the hardware stores, a plumbing supply, and you see this big thing. It looks like a wig hanging up on the wall, and it's the hemp that they use to make up their threaded BSP joints. Now here's a straight thread. A lot of the products that we make, if we're going to put this together with a gasket connection, that will be a straight thread. So don't buy one of these and try and put a female adapter on it. That's not the type of thread it is. It needs to have a nut with a gasket between it, or again, if it's a pipe, you could put some Loctite on that and seal it. But this is a straight thread. It's intended to have a union nut on it. The nice thing about building, when we build our valves this way, is it gives you not only a good seal out here on your gasket, but it gives you a way to get back to that valve if you have to take this valve out to service it or replace it someday. Now you've got a union connection there that can be split open. The other thing this does for us, and you'll see as we go through here, once we have a thread like that, now we can put different tail pieces. So if you want, a different size, or if you want a threaded connection there, maybe you want a male pipe thread. And now what we're doing is we're starting to offer all of our products with a press fitting. And so all we're going to do for this valve here, and a lot of our other valves, is just give you a press tail piece that uses the same union nut. So you'll still have your fiber gasket between it. You'll have this union nut, but now instead of this example here with a sweat fitting, you're going to have a press fitting on there to just squeeze it in there. Some nice examples of some of our big mixing valves that were put in there. It looks like a high-low station or something they're starting to build for temperature mixing there. And again, that allows you to be able to put this thing, assemble it without heating on the valve, because you can solder up all these copper connections to your tailpiece first, cool them off, put your gasket in there and assemble it, and then again you've got access to that if you have to service that or replace that someday. And that's a example. It looks like one of our, I'm putting a three-way valve or something in there. You can see that this is one of our press adapters there, and the fiber gasket. I'm going to talk about these fiber gaskets a little bit. The main thing is when you use a fiber gasket, you got to make sure that both the sealing surfaces that gasket's going to come in contact with are clean. If you've got pipe dope or you've got solder flux or something like that, you might not get a good seal. And really what you want to do with this, if you can, is moisten this gasket first. You can just spill a little bit of water on the floor, on a countertop or something like that. If you get that wet first, it starts to release the agent in there a little bit. And what will happen if this gasket was made upright, when you take this apart like a day or two later, what should happen is this gasket should be glued to both the surfaces, and then it's going to rip apart when you take it apart. And obviously you're going to have to start over with a new gasket. But that's what is intended to happen with these, is they're supposed to stick to both the surfaces when they go in there. So most of the time it's if you've got a dirty fitting, they might not seal as well as they should until you clean it up a little bit. And so here's an example of what I was talking about with our tail pieces. Now we can turn this into whatever type of connection that you want. This is one of our pressure reducing valves that we're coming out with here, a 3/4 inch pressure reducing valve. So we could put a male thread on that. We could put a sweated thread, a sweat tail piece, or if you want to press on that, we can give you that also. And we're going to do that on our bigger, like our separators here, our hydro separator and the combination dirt and air separator here. We can just change the tail piece for whatever type of configuration you want. Now over here on the brass, on some of our brass products, we're actually going to Loctite that press tail piece right into it, so you don't have to do that on the job site. Just take this out of the box and make up your connection there, and just squeeze it in. You're ready to go. So we'll do the work for you at the shop, and you can just take it out and install it and press it in. And this is getting a lot of traction out there, the press type of fitting, because what's happening is a lot of the bigger cities that I go and do training in, if you're going to be using the torch especially on commercial jobs, but even some of the residential applications, you have to get a burn permit or a hot permit or a fire permit. And in fact, I was just down on a job here last week down in Guantanamo Bay. Excuse me. We had a 1/2 inch solder joint in an expansion tank that was leaking. We had to go down to the fire station, notify them that we're going to have a torch on there. Then we had to find somebody on the base that had a hot permit that could watch us while we were soldering that and make sure he was the burn watch guy. So with that much involved in having torches on the job, you're going to see more and more guys looking to other ways of making connections on the job. And I think the guys that like to work with copper, probably this is the next evolution in fitting, would be the press. And the nice thing about this is there's more options available there for fittings for the type of tools that we use to do that. They've got little cordless tools like this now that you can get if you're working up on the roof or something, like you don't want to drag a cord up with you. You can take a little cordless version of this tool, and I think we can squeeze all the way up to 4-inch pipe size. I think right now, Mike, we're going up to 2-inch on our press fittings. We'll keep an eye on that. If we have to go bigger and we get enough demand for that, we'll look at bigger sizes. But right now, we've got the press fittings available from, you can show some here, from 1/2 inch all the way up to 2-inch. And so there's an example of one of the press tail pieces that we put together. Now, when you use a press fitting, you want to be aware of the prep work. You can buy these little reamers, and I like this reamer here, and what it does the inside of the pipe. So if you cut that with a tubing cutter, you want to get that burr out of the inside, so it's got a kind of an umbrella or tapered reamer that'll get the burr out of the inside. Then you flip this tool over, and the other end of it will do the outside, because when we slip our pipe into the end of this fitting, there's an O-ring in here, and if the edge of the pipe is sharp, especially if you cut it with a hacksaw or something like that, where you got you know, a little bit of saw burr on the end of it, you could possibly cut a nick or cut through that O-ring. So at the very least, take some emery cloth or something like that and go across the end of it, so when you slide it in there, you don't compromise the gasket. And because that's really the integrity of this joint is the gasket in there. The press is what's holding it together. It's the gasket that has to make the seal. The other thing I would caution you on a press fitting, if you've got copper tube that's got a bunch of scratches or marks in it, sometimes guys will drag the stuff across a concrete floor when they unload it from a truck, or maybe at the supplier or something like that. It got damaged on the end of it. If you've got some heavy scratches in that, it's not going to make a very good seal in there. So just cut it back to where you've got a good you know, clean end on it, and you don't have any scratches or any burrs on the end of it. Or if you drop it and it gets a little bit egg-shaped or out of round, it's going to be tough to get it in there. Just you know, sanded it and you got the burrs out when you put it together. Now, what we've done on ours is we have a ring inside here that's got a multiple leak path. So if you put one of these together, let's say you've got a whole wall full of piping you put together, and you're at the end of the day and you start putting water to it and you forgot to put the tool on one of these and crimp it shut or press it shut, what will happen is the water will leak out of the leak path that we put in there. So in our rings that we have in there, it has probably 9 or 10 different paths in there that it can leak. So if for some reason the leak path is at the back of the wall, you might not notice it. So by putting, and I think got some pictures coming up of that, by having a ring in there with multiple leak paths, you're assured that you're not going to miss one of these that you walked away from and left it unpressed. There it is, exactly what I was talking about. So you can see an end view of our O-ring there. You can see all the different leak paths in there. So no matter where on the wall you would have this, you're always going to, it's almost like a shower head when it leaks out of there. It just sprays out all around those different leak paths. And so here's an example of our Z1 valve. So now we can put that valve and we can put those connections on the end of it. And we took it a step further. So what we're thinking with this here, this is one of the first products we looked at putting pressed tail pieces, because this could be a retrofit product. So maybe you go to a job where you can no longer find an actuator for a zone valve that's obsolete, or you want to just change the brands to a different style of valve, whatever it might be. By putting the pressed tail pieces on, now we can go and we can just cut the old valve out. We can actually press these tail pieces in and then make the union connection. So now we've got the ability, if we have to get in this valve someday, to, on the Z1 valve, you can actually drop the bottom out of this and get in there to, if you got something stuck between the flapper and the seal surface in there, you can get in there and work on it. Or if you have to take it out and replace it, maybe you put the wrong CV valve in, or who knows, if you want to take that out, now you've got a union connection. Even though you pressed it in with a permanent connection, you've still got the ability to get in there and remove that valve and work on it, replace it. And an example of some of the contractors that are using our pressed, our Z1 valve with the pressed tail pieces on the end of it. So when we came out with that, we said, well, let's make a little video and just kind of demonstrate how this works. So what I did is I just soldered an old valve that I had kicking around the shop in a piece of pipe here mounted on there. And so we did this video, and I think we timed it. I think it was like 3 minutes from when I opened this thing up, cut through that. I'm using a little cordless saw there, cut the old valve out, did the prep work and put the new valve in. And I even had, I don't know if you can see it at the end here, a little hose connected to that, so I had water. You can see it maybe in the picture here. I had water running through it. And that's another nice thing about using the press type of fitting. If you've got a job where you can't get all the water out of the tube, way you're going to solder a joint, if you've got either, you know, even a little trickle of water coming through that, or even water laying in a low spot in the pipe, almost impossible to, you know, get a good solder joint when you have water in there. So with a press, what I did here is I had water running through this. As I cut the old valve out, put the tail pieces in, put it in, and put the tool on it and squeezed it in there, and away you go. So I think most people start out with press tools mostly as a repair tool, then see the value of the time savings and the labor savings in using that type of tool, as opposed to having the torch and the solder and the flux. And I see more and more of the press going out there. So then we looked at that and we said, well, what if you've got a valve that's a little bit longer and, you know, you don't have enough pipe room, enough dimension in there to put it in. So now we make an extended tail piece for it. So if you have to cut out a valve that's a little bit longer in lay length, we call that, or the dimension of the valve, by giving you this extended tail piece. Let's see, I got another picture of that. You got a little bit more room to work and take the old valve out and put the new valve in. Yeah, so there's an example. So you can see the face-to-face, what I call the lay length of the valve from where, the old valve that you're taking out, if it's that long, now you need to make up that difference. So by giving you that extended length on that tailpiece on that one end, now any one of these valves you could take out and replace it with our Z1 valve and squeeze it in there. And this is typically the way guys will put in a Z1 zone valve like that, is they'll take the actuators off the top, and thanks Eric for this great looking job, by the way. Squeeze them all in, get them all set in there, and then go back and put the actuators on and wire them up. Some guys will even wire up the actuators before they snap them back onto the bodies here. And now again, you've got isolation valves there, always a good idea. So if someday somebody had to get back into that valve for whatever reason, he's got a valve down on his header pipe, you got an isolation valve there, you could get in there, you could either remove it or you could replace it or you could service it without knocking the whole system down. Just some more examples of that. The other thing, you can get them nice and tight together with this type of fitting, so you can see just enough room to get the actuators on there, maybe ½ inch of space between all those. The tongs that we have on the new press tools will work in that tight of a dimension now, so you can get things nice and close, and if you're working in tight quarters or something like that. And so here's an example of one of our dirt cals. It's our magnetic version of our dirt cal here, and you can see there's where we've put the tail pieces in. So we just basically start with the threaded body, Loctite the tail pieces in, you take it out of the box, cut it into your piping there, and squeeze it in, and away you go. This, by the way, I mean, the more that people are going to ECM type of pumps, the more people that are coming to us for different magnetic solutions on our dirt and our combination separators, just to protect these electronic motors. We've got permanent magnet motors in here. That's what we're doing with the bands. I know we've talked about that in other webinars, but that was a good example of the perfect application for a magnetic type of separator with those high efficiency pumps in that piping. Yeah, just some more glamour shots here, I call them. So here you can see one of our mixing valves. So they're using this to knock down a temperature for a radiant zone on this. So they've got a thermostatic mixing valve going to a probably a radiant zone off of this board here. And again, there's our thermostatic mixing valve with the temperature gauge on it. So he gets his pump running, and he just adjusts the top of the knob there, and he can dial it into exactly what he needs. And now he's got the ability to take that valve out and service it if ever needed it. And there's our hydro separator. That's actually our SEP4, our 4-in-1 device. So what we've got here, we've got air separation, dirt separation, hydraulic separation, and also a magnetic band on it. And you can see with the press tail. So that takes even more labor out. I mean, this to me is one of the biggest features of using the separator on a job. It can take hours of labor instead of doing the old primary, secondary with the closely spaced tees and building and soldering and all that. So you take the the separator out of the box, mount it on the wall, make the 4 connections, and away you go. And now with the press, now it makes it even quicker. Now I don't even need a torch on the job. I don't have to sand, I don't have to flux, I don't have to heat it up, I don't have to wipe the joint, I don't have to clean it, take it out of the box, make all my piping connections here. You could probably, and I'm sure that's what Ed did on this job, make all these connections up at once and then just go at the end and press them all at the same time. And what that allows you to do, now you can plumb everything up and get it nice and straight. One trick I learned, that when guys press these, what can happen with a press joint is when you put the tool on there and squeeze it, it can kind of distort the fitting a little bit. And so, and I learned this from some of the people at the ASHRAE show, the NIBCO booth. I stopped by there and he said, flip the tool over and press it from 2 different sides. So press it from the top down first, and then if you got room, press it from another dimension. He said that'll take any misalignment that you might have got by just squeezing it from one side and bring it back in the plumb. Most of the guys are going to do this. They're going to get everything mounted nice and solid with Unistrut or something like that. So when they do press it, things aren't squirming around on you, so it looks nice and straight when you're done. A learning curve like anything else. When you go to a new method of piping, a new method of fitting, there's a little bit of a learning curve until you get comfortable with it. I don't know who that knucklehead is, but that's a cutaway of one of the products that we had at the show in Toronto here a couple weeks ago. Again, another magnetic separator. And so there's kind of an overview of what we got available right now for our press fittings. You can see we can go all the way up to 2-inch on some of our separators. Some of the products, like I said, will have the adapters built right into them when you get them. Other ones will be as a tail piece here. Anything that has this 1-inch G-thread, which is a lot of our components, by the way, our balancing valves, our mixing valve, thermostatic mixing valve, our zone valves, this pressure reducing valve up here. The nice thing about that, having this 1-inch G thread right here, now you can select, you can even mix and match. If for some reason you wanted a thread on one end to go maybe to an iron steel pipe header and you wanted to go to press, you could turn this into a transition zone valve. So I'm going to thread, I'll put a straight threaded nipple on one end, screw it into my manifold, and then I go to a copper press on the other side. So we do sell these fittings separately. So if you need to buy I think we got a 1, 2, and a 3 kit of them. So if you're doing a 3-way valve and you need 3 of them, you can buy a 3-pack of these. We also, I don't know if you can tell in this picture here, we've got our temperature gauge now is available with a press tailpiece on it also. So if you like using our temperature gauges, which a lot of people do for both domestic water or radiant, now you've got the press fitting built right into the gauge well tailpiece, we call it. I'm trying to think what I want to talk about. Oh, so what we've got here is some dielectric unions. So I know there's a love-hate relationship. Any plumber out there that's ever used a dielectric union just cringes when the inspector demands that they use them. I mean, there's a purpose for this fitting. I mean, basically what we're trying to do here is there's electrical disconnection between the copper and the galvanized pipe here, and they do that with a fiber washer around the outside of the tailpiece here, and then there's a rubber and EPM gasket between it. So basically what you've done is you've disconnected the metal on this side from the copper on this side, so you can't get electrolysis where you've got dissimilar metals together. Well, I mean, they tend to plug up. They seem to bring as many problems as they do solutions, but I know a lot of inspectors, if they see a water heater or something put in like this, they're going to insist that you have a dielectric union. There's other excuse me. There's other ways that you can do this. A brass nipple would do a similar thing where you're disconnecting the two dissimilar metals, so the galvanized here on the nipple and the copper by using the brass, or some guys use stainless steel nipples. I'll show you some of transition fitting ideas I came up with products that we've got in our catalog here. Another thing about this, obviously, this is 2 domestic water heaters. He's got looks like a domestic water recirc pump on it, a bronze pump there. And notice what he did here is he put a couple of our quick setters in. So you've got 2 tanks, and you want to make sure that you get the exact same amount of flow between these 2 tanks. So instead of doing a reverse return or making sure that the dimension from all these pipes are exactly the same to get a balanced flow, he's put a couple of our quick setters, our 132 quick setters on there, and now he can just get the pump running and get the flow running. They just dial these in, so he's getting the exact same amount between both those tanks. So that was a great way to use that our quick setter in a low lead version. Of course, if it's going to be on domestic water, you got to use the low lead version. We do offer these in both versions as a low lead for domestic water and a hydronic version of it also. Another example of a dielectric union there on one of our thermocon tanks. So you can see he's gone from the 2-inch connection here. A nice way to do this, by the way, Mike. So he's gone from a 2-inch connection, a threaded connection there, down to what, 3/4, 1 inch possibly, and then use a dielectric transition between it. I mean, that one of the nice things about dielectric, it does give you another union connection. I don't know why you'd ever need to, get in there unless the tank would fail someday and you could take it apart. But excuse me. So here's an example of a compression fitting. So this is a whatever tube. It could be a polyethylene, a PE tube, or a geopex tube, or a polypropylene, whatever type of tube you're using. And basically where the connection is, the integrity of this connection is on the O-ring here, and then you'll have a nut, and then you'll have a ferrule, I call it, or a grabber ring in here. So really what the nut and the grabber ring does, it makes sure that this can't squirt apart when you put the pressure on it. The seal is really being made here, and then this mechanical joint, I guess you would call it, this compression nut and this ferrule inside here. On our PEX fittings, we offer it both ways as a plastic ring. On regular PEX, if you're using aluminum PEX, we offer it with a brass compression ring in here that grips into the pipe a little bit better. So key to this type of fitting, like anything else, it's got to be clean. The other thing I find with guys, and sometimes with this type of fitting, if you're using one of those scissor cutters and you don't get a nice straight cut across the top of this, if you got an angle cut on that, your ring might not be sealing all around. So make sure when you're cutting with a scissor cutter or knife, if you're whatever you're using to cut your plastic PEX and PEX, whatever tube you're doing, that you get a nice straight cut across the end of it, so you're into the fitting deep enough that you're going to make sure you've got contact with your O-ring and get a good grip on your ferrule there. Excuse me. And over here on the right is one of our geo manifolds, and you can see there's some compression fittings on the geo manifold. We've got the quick setters on there, and that's just some regular geo tube that's being used there. It's not a PEX, it's just a PE tube. Geocal fitting, we call it. Another example there of the pretty much the same fitting. Nice job there, by the way. He's got a little electronic pump, and he's got a nicely piped job. We also use a type of compression fitting on our radiator valves or thermostatic valves, and our H valve, this is called. This might be at the bottom of a panel radiator or towel bar or something like that. And this is going to have a compression fitting that'll go on copper tube, or you could also use PEX tubing. The same thing here. We've got a nut, we've got a compression ferrule in there, and we've got an O-ring seal that's being made from the tube to the nut. We also, I don't know if many of you guys know this, but we have a nice little discussion for this. So if you're coming out of the floor or coming out of the wall and you want to trim this out, this one's got a little bit of adjustability by having these fingers in it. So if you're trying to clean up the pipings coming through the wall or the penetration through the floor, we've got a discussion for that. Now this is an example of a copper compression fitting. So if you're coming out and you want to go to a thermostatic valve, in this case here, one of our isolation valves, and you want to use copper pipe instead of PEX, it'll have this adapter right here. And so what you see here is you've got the copper comes through there, and there's your compression ring, there's your O-ring seal, and there's your ferrule on the end of it. So it's just another version of a compression fitting, but it's made specifically for going onto these valves with copper tube or a PEX tube if you buy the other type. We've got some of these. This is a convertible valve. So this is a valve that if you want to use it as an isolation valve with just a knob on it, for on one side you got a thermostatic valve you're going to put on the other side, you can change this valve and put an actual thermostatic head on it down the road. Now I'm looking for time here. I got 10 minutes. I better keep rolling. Excuse me. Bar none, I think this is the nicest PEX fitting out there. I'm a little partial to this fitting, of course, but what we've done is we came up with a universal PEX fitting, and how we did that is we take a regular nut here and we take what we would call an olive, maybe because it's made in Italy, but this is what's called a segmented olive, and what that'll allow this ring to do is if you've got a tube that's a little bit out of tolerance, or maybe it's a little egg shape, or it's the OD of that wasn't extruded exactly right, you've got a lot of adjustability by having a slotted ring like that. And then this part that goes inside the PEX tube, this is, I don't know if you can see it in the picture, it's actually tapered, and it has a double O-ring seal. So we've got two seals that are being made there, and by this, as you get further up into this gets wider up inside here, so it's tapered. So if you got an ID tolerance issue, this is going to straighten it out. It's going to get a double seal. And then the seal to the manifold itself is made with I call this a nose O-ring. We've got an O-ring at the end of that that's actually sealing there, so you don't have to put pipe dope or a great big wrench on that trying to get that to squeeze against a brass-to-brass connection. We've got a nose O-ring, we've got a double O-ring that's sealing inside the pipe, and we've got the segmented olive to make sure that we get a good grip on the tube if we got a bad tube or something like that. The other thing, I don't know if we got a picture of this coming up, but inside this, what we do is we taper the hole going through that isn't just a straight hole going through the center of it. It's actually tapered kind of like a Venturi. So we get about a 20% better flow rate through our PEX fitting than some of the other brands where they just drill one hole through. We actually, on both ends of that, it's got a taper to it for a better flow path through it. This is what I call barbed insert fitting. Call it what you want. It's called a crimp fitting. There's different ways you can do that. That's a copper crimp ring. So the barbs go inside there. The crimp ring makes the connection. This is, I think that was originally called an Oetiker. I think was the designer of this type of clamp. So you just use a tool here that pinches two tabs together. Pretty much doing the same thing as a copper crimp ring. Some of the other brands will use a stainless steel collar on here, but they're all just dependent on the barbs inside the pipe to make the connection, and then the crimp ring is what holds it all together. Inverted flare, we do offer inverted flare tail pieces for our zone valves, and again, that's very popular up in Minnesota and Wisconsin. There's a lot of guys still using inverted flare. It gives you just one more connection there that you can take that valve apart. So I think most guys know what a flare is. That's just basically a tapered cone shape to the end of that goes to the body of the valve, has the opposite cone shape to it, and the tailpiece makes a seal against the flare inside there. That looks like just some CPVC plastic to me there, and if you're going to go to one of our flange fittings, then you'll need to buy one of these transition flanges here that go from the CPVC or PVC, that's probably a geo loop or something like that, into one of our combination dirt and air separators with a flange connection. Another example of there, nice that he's put a couple butterfly or wafer valves on this, so if ever you have to isolate that to work on it whenever you've got isolation on it, and it makes a transition. So there's an example how you can make a welded connection. You would buy this companion flange, and you can buy a flange that's threaded. You can buy sweat versions of that, or you can buy a flange that you actually weld onto the pipe, and then it gets assembled with what we call a bolt kit. Bolt kit comes with the gasket and the proper size bolts to make that connection. You know, you want to torque those to the right amount of torque so you get just the amount of pressure on that gasket to seal it, but not too much where you're going to distort the flange when you put it together and warp it, and then you could have a leak. So, and that's what this handy Andy down here on the right is doing. Groove fitting's been around forever. You see a lot of this. Mostly I see this in fire protection systems. You know, if you look in a building and you see all the fire sprinkler heads up there, they'll groove it. Basically, they either roll a groove in there, or sometimes they cut a groove in the end of the pipe, depending on the type of material. And then these collars grab both of those grooves, and then there's a gasket between them. So, again, if you want to go to our fitting, you would need a transition flange to get from the groove to the flange that we have on our bigger welded steel vessels. And just another example of a groove fitting. More groove fittings there on a big, I think this is one of our excellence entries from last month. And there actually is a groove fitting for copper too, where they, most of the time they roll this groove instead of cutting it because you don't have a lot of wall thickness there, but there's actually groove fittings that are made for copper, and I've seen that in the fire sprinkler industry too. I think really it comes down to what you're most familiar with, what kind of tools your shop has to work with this. Probably one of the newest products you're seeing out there now is this this type of fusion weld pipe. In fact, you can buy this all the way up to 24-inch. Through this here, we've got some more, again, just some glamour shots here of some of our product nicely installed, by the way. Thanks for these pictures of, looks like Aquatherm pipe there on one of our hydro separators. A big geo loop field that was put together with Aquatherm, and he's put a quick setter on every one of his loops to check and confirm his flow rates. I like that with all the gauges in it there, but you can see some steel pipe, some flange pipe there, some welded pipe, a little bit of everything this wrong, really welded, flanged, threaded, pretty much the whole gamut there, copper, steel. So transition fittings, if you someday when you have time, look through our price catalog, and we've got all these different tail pieces, and you can mix and match these tail pieces. So there's an example where I put sweat together with a press fitting. There's an example of transition fitting where I went from a press to a female threaded. If you need a hand with that, if you're not sure what numbers go together, how to do that, we can make a lot of different, we can go to brass, BSP brass to a copper. We can offer a lot of different ways that you can transition or make union connections. So let us know what you need with that, and we'll help. We'll guide you through the selection of those different adapters to make that. I talked about this a little bit earlier. If you're having problems with the green gaskets not sealing, just moisten them a little bit. Take a cup of water along with you or something. Drop them in there for 10 seconds. Get them wet. Get them a little bit moist, and they tend to seal a lot better when they're wet. Thanks again, everybody. We had a great turnout today. We appreciate everybody supporting the Coffee with Caleffis. Let us know how we can help you with upcoming webinars, what you want us to talk about. If you want to come on and join us and you have something to talk about, let us know. We'd be glad to get you on as a guest host or guest speaker and participate in it. So thanks, everybody.